For 26, to multiply this, just write it twice and FOIL it out. So you cannot just distribute the squared. You got to write it twice and FOIL it out. I'm sure you guys know how to FOIL, so we're going to skip. But just make sure, if you have an I squared, what does it turn into? -1. For 27, to solve when x is in the exponent, I can put it into log form. So I'd want to make both sides log base 5. So the log base 5 of 5 cancels, yes. So this would be 3x is equal to log base 5 of 6. Some calculators will let you put this into the calculator, but some you have to do the change of base formula. So that would be log of 6 over log of 5. When you put that in the calculator, you should get 1.113. And then the very last step is just divide both sides by 3. So x is equal to 0.371. All right, how would I find the x-intercept? Make y 0. So I'd make y 0 and then solve. How would I solve an ln function? Make the big base e. So the big base e of ln will cancel, and then I'm just left with x minus 7. What's e to the power of 0? 1. And then we just add 7 to both sides. So x is equal to 8. Do the same thing for b. We make y 0. How do I get rid of the log in part b? Make my big base 2. So I have x minus 2 is equal to, what is 2 to the power of 0? 1. And we add 2 to both sides, so x is equal to 3. How would I solve 29? Awesome. Whenever you have a log is equal to a log, you can cancel them out, and then just set the rest equal to each other, and then solve. For 30, we have to find the domain and vertical asymptotes. How do I find the domain and vertical asymptotes of a log function? So to find our vertical asymptotes, we set what's inside the parentheses equal to 0. So for our vertical asymptotes, we'd say x plus 3 is equal to 0. So x is equal to -3. So our log function, instead of having a vertical asymptote at 0, we just shifted it to -3. So now our log function looks like this. What do you think our domain is here? Perfect, -3 to infinity. And they both get parentheses because we'll never touch that -3 asymptote. We get really, really close to it, but don't touch it. So both get parentheses. 31. What is log base 9 of 9? 1. Perfect. For 32, how do I convert to radians? Times pi over 180 and simplify. How do I convert to degrees? Times 180 over pi and simplify. How do I find a positive and negative coterminal angle when I have degrees? So you can add 360 or subtract 360, depending on which one you need. So I'm going to add 360 to find a positive coterminal angle. So what would we get? 235? Close. Then negative 125 minus 360 would be negative 485. But don't worry, you guys get a calculator, so just put it in there. Now, what do I have to add when it's in radians? Plus or minus 2 pi. So we would add 2 pi How would I add 2 pi to this? I need a common denominator, so I can make this 14 over 7. So that would turn into 25 pi over 7. And then to find my negative coterminal angle, I can subtract 2 pi. So do the same thing, make it 14 pi over 7. So that would be negative 3 pi over 7. Good with these? How would I find the complement of an angle? So the complement would be 90 minus the angle. Supplement would be 180 minus the angle. What about if it's in radians? Pi over 2 minus the angle, and pi minus the angle for supplement. (36). How do I find the arc length? S is equal to R times theta. What does theta have to be in? Radians. So what do I need to do before I start plugging in? Convert it to radians. So I would multiply by pi over 180, which changes this to 5 pi over 4. So now I can plug in my R and my theta. So S is equal to 6 times 5 pi over 4. So S is equal to 30 pi over 4, which simplifies to 15 pi over 2. So for 37, we have to find the radian measure of the central angle of a circle of a radius r that intercepts the arc length. So we're using the same thing, S is equal to R times theta, but this just gives me S and it gives me R. So I have 8 is equal to 6 times theta. So divide both sides by 6. So theta is equal to 8 over 6, which simplifies to what? 4/3. So 38, a point on a terminal side of an angle theta is given. Find the exact value of the indicated trig function. So here I can graph the triangle if I wanted to. We can do that. So negative 9, 12 would be to the left 9 and up 12. So up there. So x would be negative 9 and y is 12. Now I have to find my hypotenuse here. To find r. A squared plus b squared equals c squared. So negative 9 squared plus 12 squared is equal to c squared. So this would be 81 plus 144 is equal to c squared. So 225 is equal to c squared. So what would c be? 15, awesome. So your theta always comes from the center here, so my theta is here. Cosine would be what over what? It would be x over r, or adjacent over hypotenuse. Same thing, just thinking about it 2 different ways. So it'd be a negative 9 over 15, which simplifies to what? Negative 3 over 5, thank you. And cosecant is what over what? Hypotenuse over opposite. So 15 over 12, which would be 5 over 4. For 39 and 40, we're back on our log functions. How would I solve 39? So what's the base here? 8. How can I move that 4 to the other side? Divide by 4. So I have 8 times 8 to the power of x minus 1 is equal to 8. I can cancel it. What am I left with on the left side?
No.
I mean on the right side. On the right side. Just 1. Because it's 8 to the power of 1. So if I'm canceling out the bases, it'd be x minus 1 is equal to 1. Then we add 1 to both sides. So x is equal to 2. Take the log base 8 of both sides. Right, for 40, we are expanding. So every time I break it apart, each piece needs its own log. So I start with log base 7. What would come next? 40. Now if I break it apart, what's happening between the 40 and the x cubed? Multiplication, so then I would add it. So I'd have log 3 log of x, log base 7 of x. And then what would come next? Perfect. Minus 5 log base 7 of z. So every time we break it apart, it needs its own log base 7 for each piece. And then remember exponents, since this was technically x to the third power, exponents get moved to the front. So for the next one, we have to condense. So with addition, I have to multiply. And then the coefficients go up top and become exponents. So this would be log base 8 of x plus 3 to the 5th power times x minus 6 to the 1/3 power. If this was multiple choice, you may see it as log base 8 of x plus 3 to the 5th power, and then the cubed root of x minus 6, because the cubed root is the same thing as saying 1/3 power. And then it would probably have brackets around it here. All right, the next question said, determine the quadrant? Yeah. So what's the acronym that I use? All students take calculus. So sine is positive. So which 2 quadrants can I cancel? The T and the C. And then secant is negative. So which one can I cancel? The all. So we're left in the, which quadrant? Second quadrant, quadrant 2. So looking at 43. So we have to graph the following. So it helps to know A, B, C, and D. How would I find my starting point? C over B. So C is what? Pi. Remember, you switch the sign of your C, so it's positive pi. And then B is 4. So we would start at pi over 4. Now, cosine, does it start at the amplitude or at the 0? At the amplitude. So we would start up at 3 at our starting point. So we start there. That's our first point. Now, typically, if we didn't have any shifts, we would start here at 0, 3. But we shifted it in which direction? To the right. So this is called a phase shift to the right. So if the question on the midterm asks to describe the phase shift, you would just have to find your C over B and figure out where you start from 0. If C over B was negative, which way am I shifting? To the left, because we would shift to the left to be at your negative pi over 4, whatever it may be. So this would be our phase shift. So the starting point is the same thing as a phase shift. All right, I also need to know my increments. and the period. How do I find the period? 2 pi over b, so 2 pi over 4, which would just be pi over 2. And then how do I find the increment? The period over 4, so pi over 2 over 4. Be careful here, when you have a fraction and a fraction, you're doing keep, change, flip. A lot of people still make this mistake. So it's 4 over 1, but we flip it to be 1 over 4. So this would be pi over 8. That was probably like the most common mistake on the last test, was the keep, change, flip part of it. So I add pi over 8 to get from one increment to the next. So it would be pi over 4 plus pi over 8. So I would have to change pi over 4 to be 2 pi over 8. So that would make this 3 pi over 8. Then I add another pi over 8, so 4 pi over 8, which would be what? Pi over 2, perfect, because we always should simplify. Then I add another pi over 8, so that would be 5 pi over 8. And then one more, I have 6 pi over 8, which simplifies to 3 pi over 4. So with cosine, we said we start up top at the amplitude. Where would I go next? Back down to 0, then back down to -3, back to 0, and then up at the amplitude again. So this would be my graph. So if this asks for like more than just one period and we continued our graph, like this would be a full parabola. But it's just a half parabola just because it gets cut off. All right, let's look at 45. I'm going to change 45 a little bit. Actually, I'm going to change it a lot. So I'm just going to make a new question. Let's make it sine of 4x, and then outside, let's say we are adding 2. So we've talked about how a negative does what to our graph? Reflects it. It's a reflection on the x-axis, so we would just flip it upside down. And then what does the +2 on the outside do? Move it up 2. Now these are both things we've said to save for last, but the order that we do it in is important. The reflection happens first. So you want to flip it before you move your graph up 2. So the up 2 would happen second. So let's do this one. So I first want to figure out my starting point. Starting point is C over B. What's my C here? 0. So 0 over B, which is 4. So 0 over 4 would be 0. So I start at 0. Yes. Yes, the 2 is D. If you're adding it on the outside, that's your D. That tells you if you move up if you're adding it, or you would shift it down if you're subtracting. My amplitude is 5. So 5 and -5. Next, I want to find my period and the increments. How do I find the period? Two pi over b. So 2 pi over 4, which would be pi over 2. And then how do I find the increment? The period over 4. So that would be pi over 2 over 4. So keep, change, flip. So it'd be pi over 8. So from 0, I'm going to add pi over 8 to get to my next increment. Then pi over 8 plus pi over 8 would be 2 pi over 8, which would simplify to what? Pi over 4. then I have 3 pi over 8. And then 4 pi over 8. Which, what does 4 pi over 8 simplify to? 2 pi over 4. Nope. Pi over 2. So our sine graph starts where? At 0. Then we would go up to our amplitude, but instead of going up, which direction do I need to go? Down, because I have a reflection. So down, then back to 0, then up, then down. So we applied our reflection first. And then the +2 means that I go which way? Up 2. So every one of my points, I'm just going to shift it up 2. So every point we're shifting up 2. So that would be my graph. Yeah, I shifted it up 2. If a question was multiple choice, like this one, I would maybe not graph the entire thing. Use your answer choices to help you. Notice that it's a reflection, so your graph is going to start going down instead of going up, and then we go up 2, so just look at the one that shifts up 2. So use your answer choices to help you, but it's important that you apply the reflection first and then move it up 2. Our normal sine graph would go like this, but the reflection we flipped upside down, so instead of going up, we went down. All right, so this goes back to our log and exponential section, so it's kind of out of place, but it's fine. How would I solve this? I could substitute like just x for e of x, so I'd make it 2x squared minus x minus 6. I could do that. Once it looks like this, what do I need to do? Factor. So from here, we know how to factor. You don't have to substitute the x, so all I did was change the e of x and made it x just to make it a little bit more familiar so we could factor, but we're going to have to change it back to e of x.
And how did you get 2x?
Because it's e to the power of 2x. So like that is technically like x squared.
Is there a lot of these questions?
Right, so from here, we factor normally. So 2 times -6 would be -12. Do I have two factors of -12 that add to -1? -4 and 3. So this would be x minus 4 and x plus 3. What do I have to do next? Divide by 2. So x minus 2 and 2x plus 3. Now I'm not done yet, I just factored, so I did the hard part, but I still have to solve. So I'm just going to change those x's back to e to the power of x. And then just like we would solve a normal factoring quadratic question, we set both pieces equal to 0. And we solve. So for the first one, I add 2 to both sides. E to the power of x is equal to 2. What would I have to do to solve for x? Take the ln of both sides. Awesome. So x is equal to the ln of 2, and you would just put the ln of 2 in your calculator. So x is equal to 0.69. Now we have to do the same thing for the next one. So I would subtract 3 on both sides. Divide by 2. Then we take the ln of both sides. What happens when you put the ln of -3/2 in your calculator? Error. So this one does not work. It does not work out. So we only have one answer. So make sure you know how to factor for tomorrow. If something doesn't factor, what do we have to do? Quadratic formula. Negative b plus or minus the square root of b squared minus 4ac. Perfect. Make sure you know the quadratic formula for tomorrow. All right, so 47, we have to give the exact value of the trig function. So sine of theta. Sine is what over what? Y over r, or you could say opposite over hypotenuse. That would work too if you just know SOHCAHTOA. Let's figure out what quadrant we're in. So I have all students take calculus. Sine is positive, so which two can I cross out? Tangent and cosine. Because it has to either be in the all positive one or the sine positive. And cotangent's positive. So which other one can I cross out? Sine. So I'm going to be in the first quadrant. Now my radius is 4. And my y is square root 10. So I still have to figure out what my x is or what my adjacent is. So how would I find that? Pythagorean theorem. So 4 squared is equal to square root 10 squared plus, we can say x squared. So 4 squared is 16. What's the square root of 10 squared? 10. So subtract 10. 6 is equal to x squared. So x is the square root of 6. Now it is asking us for, it doesn't say. We'll just find all of them. So sine was given. Let's find cosine. What's cosine of theta? Adjacent over hypotenuse, which would be what? Square root 6 over 4. Perfect. And then tangent. Square root 10 over square root 6. Can I leave it like this? No. Multiply the top and the bottom by square root 6. So this would be square root 60 over 6. We can simplify this. Let's see. What are 2 factors of 60? 6 and 10. 2 factors of 6. 2 and 3. And 2 factors of 10 would be 2 and 5. So this would be 2 square root 15 over 6, which again simplifies to square root 15 over 3. So that would be my tangent. Let's find our reciprocal functions. So for cosecant, I'm just going to flip the sign. So that would be 4 over square root 10. But we still have to rationalize. So this would be 4 square root 10 over 10, which again simplifies to 2 square root 10 over 5.
You can't simplify within the radical, right?
If you can't simplify the number in the radical, then you just leave it. So like, what are 2 factors of 10?
One thing is like, let's say there was like a 10 at the bottom and 10 in the radical.
No, if it's like a real number and a rational number, you can't divide into it.
If it's 2 radicals, can you divide and then rationalize?
Yeah, so for like the tangent that we had,
That's what I was thinking originally.
yeah, it was, which would be easier if you did it to start, so square root 10 over square root 6. You can make it all under 1 radical and then simplify, which would be 5 over 3. And then rationalize. Because like we would have to split it back up and multiply the top and the bottom by square root 3. So I think like simplifying it before would be easier, but they both work. All right, let's find secant. So secant, I'm going to flip the cosine. So that would be 4 over square root 6, which we would have to rationalize. So 4 square root 6 over 6, which simplifies to 2 square root 6 over 3. And then lastly, I have cotangent. So I'm just going to flip the end result that I have because I know that that one's simplified. So that would be 3 over square root 15. Rationalize, so 3 square root 15 over 15, which would be square root 15 over 5. So you have to know S is equal to R times theta. What does theta have to be in? Radians. So our compounded interest formulas are A is equal to P times 1 plus R over N to the power of N times T, and PERT. P times E to the power of RT. These are the compounded interest ones. When would I use the PERT one? Compounded continuously. All right, but just so we know, what's the P? The starting amount. How much do we start with? What's R? The rate, but it has to be the decimal version. So you move it to the right twice. So if it gives you like 5%, what's the decimal version of that? 0.05. So you just move the decimal to the left twice. What's our N? The number of times it happens in a year. So yeah, that's like the quarterly, monthly. What if it said annually? How many times does that happen in a year? Once. What if it said daily? 365. What if it said weekly? 52. There's 52 weeks. And what's T? Just the number of years. All right, so let's say I had a log question. If I had log base 7 of 3 square root x, and it said expand. How would I expand this? Plus, but I can still simplify it. Perfect. We would change x, the square root of x, to be x to the power of 1/2. And what do I do with the exponent? Put it in the front, just the front of that log, because that's the only thing that has the exponent. So log base 7 of 3 plus 1/2 log base 7 of x. So be very careful whenever you see a square root, you can change it to be an exponent. What if I had like the 5th root of x? What would that change? What exponent would that be? X to the power of 1 over 5. All right, I also want to do one that is, let's say, x squared plus 3x plus 4 over x minus 2. And it says, find the slant asymptote. How do I find the slant asymptote? Awesome. To find the slant asymptote, we divide. So you put the top inside the box, so x squared plus 3x plus 4, and then x minus 2 goes outside. All right, so let's do long division. So how many times does x go into x squared? Once, just x times. So x times x would be x squared minus 2x. Change the sign, and combine. So this would be 5x. Now what times x gives us 5x? 5. So then we multiply. We get 5x minus 10. From here, we can stop. Your slant asymptote is always going to be in the form of y equals mx plus b. So the rest of what we get would be our remainder, 14. The remainder doesn't matter. Remember doing this? We just keep this part. The remainder we don't care about. So our slant asymptote would be y equals x plus 5. Don't forget the y equals. So let's say I had another question that was x squared like this. Would I have a slant asymptote here? No, so there's no slant asymptote because my degrees are the same. If you're going to have a slant asymptote, it's going to be one higher than the bottom. What is my horizontal asymptote here? So here, for our horizontal asymptote, guys, listen, our exponents are the same, so I look at the coefficient. So my coefficient would be 1 over 1, so my horizontal asymptote is y equals 1. So as a refresher, if they're the same, we look at the coefficients. Let's say I had x plus 2 over x squared plus 4, something like this. What would my horizontal asymptote be here? Y equals 0. If the top is less than, it's y equals 0. If the top is more, like this one, the top is higher, the degree, there's no horizontal asymptote because we have a slant asymptote. All right, let's find our vertical asymptote. So just to make another example here, let's say I had, actually, we'll keep with this example, the one in white. How do I find the vertical asymptote? You set the denominator, well, equal to 0 because it's just going to be where it's equal. To find the domain, you set it not equal to 0 because it can't be those values. So here, I would subtract 2. So x squared is equal to negative 2. What should I do next? Square root. Can I take the square root of a negative? No. So if I have a negative, what does that tell me about my vertical asymptote? There's none. It's an imaginary line because that would make it an I, so I don't have any. There's no number that I can't plug into x that would make this 0.
So to find the vertical asymptote, you set the bottom equal to 0?
To find the vertical asymptote, you set the bottom equal to 0, yes. What would my domain be? Yeah, interval notation would work. So negative infinity to infinity. Because we don't have any number that would make this not equal to 0. Or make it equal to 0. So our domain is all real numbers. So let's say, just as an example, if we set our denominator, let's say it was x minus 4. We set it not equal to 0 to find our domain. So we add 4 to both sides. X does not equal 4. So how would I write that in interval notation? To 4. Union and 4 to infinity. All right, let's say we had x plus 2 squared plus y minus 4 squared is equal to, let's say, 16. And it said graph. What type of graph do I have here? Not a parabola, because the x is squared and the y is squared. So this would be a circle, and it has the center. The center, we just flipped the signs. So -2, 4 would be our center. And then to find the radius, we take the square root of what it's equal to. So what would our radius be? 4. So we graph our center. We go to the left to -2 and up 4. And then to draw our radius, we just go 4 in every direction. You go to the every direction 4, because that's your radius. So you go up 4, down 4, to the right 4, to the left 4, and then draw your circle.
You go 4
from the center. Yeah, you go up 4 from the center, to the left 4. All right, guys, listen. Again, there's a reason why I'm doing these questions to refresh our memory. Let's say I had x squared plus 4. And it said, find the rate of change. We did this year. Yeah. And it said x1 is, let's make it 0, and x2 is 2. Well, the rate of change is the same thing as saying slope. And do we know our slope formula? So I have my x1 and my x2, but I don't have the y's to go with them. How do I find the y's? This is given. All the pink was given. So we plug in the x's to find the y's. So I have 0 squared plus 4 would be 4. So my first point here would be 0, 4, because this is my y. I plugged it. And then I'm going to plug it into the second number, 2. So I have 2 squared plus 4 would be 4 plus 4, which is 8. So this would be 2, 8. So this is my x1, y1, x2, y2. So we plug all of this in. 8 minus 4 over 2 minus 0, which would be 4 over 2. So my average rate of change would be 2. All right, let's say one more question. I don't know if this is going to work out because I'm just making it up off the top of my head, but let's say I had x to the 4th power plus 2x squared, actually 2x cubed minus 2x squared minus 8. And let's say this said find the zeros. Can I factor this? Okay, let's say we can group them. What's the GCF in the first group? And what am I left with? What's my GCF in the second group? And what am I left with? X squared plus 4. Can I factor by grouping? No, because you don't get the same inside, so that doesn't work.
Oh, yeah. X squared, I know you gotta use synthetic.
So because it doesn't work, because we can't factor, we have to use synthetic division and use the P over Q. So factors of the last over factors of the first. So factors of the last one would be 1, 2, 4, and 8 over 1. And this is all positive or negatives of these.
So P over Q is the first number or the 100?
Last over first. So factors of the last over factors of the first. And then we just do synthetic division.
They're both plus or minus, right?
Yeah. So what would go inside the box?
1, 2,
Zero.
Awesome. Don't forget that 0 because we're missing that 0x in there. And then we would just pick any one of our options here. Again, I made this number up so it might not have any zeros, but it'll work out on the test. So let's say we had 2. Drop down the 1, multiply, add, multiply, add, multiply, add. It doesn't work. 2 doesn't work.
try -4.
I don't think -4 would work either because I think our numbers are too big. I'm going to try
We didn't do
1. So multiply, add, multiply, add, multiply. 1 doesn't work either. Honestly, I don't think that this has zeros. It probably doesn't work, but again, on
4 zeros, right?
how many zeros will we have? 4. The highest degree tells you the number of zeros. So we would have 4 zeros. So once we do synthetic division, then we would see, does it factor?
And then once
So we'd use our solution.
But you would try different numbers as you go, right? So
Yeah.
let's say you do that one and then you try a different number on your second one.
Yeah, so we would use our solution, we'd have x squared, and then just factor it normally. You could keep doing synthetic division, but once you have the 3 numbers, then just use x squared and factor.
Then you would find a new set of like P and Q.
Yeah, so let's say this was, my pencil just decided to stop working, so let's say this worked out and we got 1, 2, it worked. This would be x cubed, so we would do synthetic division again, but now we would do factors of 6 and test those. Then once we get our answers, let's say we had 1, 2, and 4, we would factor this. So what are 2 factors of 4 that add to 2? Just like that, because this would be x squared, x, 4.
I thought we even factored it normally.
Yeah, once you get your x squared, factor it normally. Yeah, the answer would just be x equals, and then whatever your zeros are, so like whatever this number is, or like when you factor it, your answers. So like a question like this, and then you just have to FOIL. And don't forget, what does I squared turn into? -1. So let's say a kite gets stuck in a tree. A kite gets stuck in a 20-foot tall tree. And the angle that the string of the kite makes with the ground is, we'll say 25 degrees. So the angle of elevation of the string is 25 degrees. Find the length of the string. So I have a tree. The kite gets stuck in the top of it. How tall is my tree? 20 feet. And the angle of elevation of the string, so that's the angle from the ground to the string, would be 25 degrees. And what is it asking me to find?
Find the length.
The length of the string. So the hypotenuse of my triangle. Perfect. So this is my theta here, the 25 degrees that was given. 20 would be what? The opposite, and x is my hypotenuse. Which trig function involves opposite and hypotenuse? Sine. So I'd have to find the sine of 25, which is equal to 20 over x. I can multiply the x, so x times sine of 25 is equal to 20. Divide by the sine of 25. So x is equal to whatever 20 divided by the sine of 25 is.
Oh my god, I think it's so pretty.
I lost.
All right, let's say this said, find the, or use reference angles to find the exact value. So we're finding the exact value. What would I do first? Convert it to degrees, because I don't know where this is on my unit circle. No, because we can use our special right triangles. So 3 goes into 180 60 times. So 5 times 60 would be 300. Yeah. 300 degrees. So this is 300 degrees, which would be in the fourth quadrant. So what would my reference angle be? How do I find that? 360 minus 300. So this would be 60 degrees here.
Second quadrant is 180 minus theta, and then theta minus 180.
180 minus theta, and then this one would be theta minus 180. Your reference angle is always going to be acute and positive. So if you plugged it into the wrong formula, you probably wouldn't get a number that's acute and positive. All right, and we're finding the sine. What is opposite of 60 degrees?
X square root 3.
A square root 3, or just square root 3. What's our hypotenuse? 2x, or just 2. We don't need it because it'll cancel out. So to find the sine, that's just opposite over hypotenuse. So the sine of 5 pi over 3 would be square root 3 over 2. Is the sine in the fourth quadrant positive or negative? Negative. So this would be negative square root 3 over 2.
No, I feel like
She knows it.
It would be 1, 1, and square root 2. So like x, and x. Yeah. All students take calculus. Only cosine and secant are positive here. So sine would be negative. But you could have, like, let's say log base 3 of x is equal to 10. So like to solve this, you would make the big base 3.
so never something like that long.
Yeah.